3M lesson 3 is called decomposition. It's going to be a good time, so we're just going to go back over what we've done to remind you some things rather strategically. So if I'm asked to expand and simplify, and I don't know why that happened, we are being asked to multiply and tidy. Multiply and collect like terms. So what I see is a FOIL. I see two binomials being multiplied, and that little memory device can help me to get all my terms. So first would be 2x times 3x, 6x squared. My outside would be the 2x and the 4, so plus 8x. Inside would be 3 times 3x, which is 9x. And my lasts would be the 12. Now we've noticed this interesting coincidence that those two middle terms often can be simplified and put together because they have the same look. So 6x squared, there are no other x squared terms, so he stands alone. The two x's can be put together, and I have a pile of 17 x's. And I have a number 12. The next thing that we did yesterday was spend a great deal of time factoring. My thought process with factoring is there a greatest common factor? Is it a nice trinomial with my two brackets? Or is it a difference of squares where I have two terms with a subtract sign in between? Okay, looking at this one, it's weird. It's certainly not a trinomial or a difference of squares, so I'm going to see if there is anything in both of those terms that's the same or common. And what I see is that this x plus 3 is common to both terms. So strangely, it would be my greatest common factor. Then I would throw up a set of brackets and write in that whatever I need to multiply x plus 3 by to get what I started with. For the first term, I had x plus 3 times 2, so I need my 2 there. For the second term, I had my x plus 3 multiplied by negative 5x. So I have that written in factored form, even though it looks kind of strange. We're going to do a bit of factoring on these two questions that might not make a lot of sense to you, but there's a method to my madness. We're going to factor by grouping. And it's going to help us with more difficult trinomials, to be very honest with you. So when I see this thing with 4 terms, and I've been asked to factor by grouping, what I'm going to do is factor these two, and then later on, I'm going to factor those two, as if they're two separate questions. So 3x cubed plus 9x squared, and I want to factor. I'm thinking about what would go into both 3x cubed or 9x squared, so a common factor. Well, the number 3 divides into both evenly, and x squared would go into both x squared and x cubed. So there's my greatest common factor for the first two. What do I need to multiply that by to get what I started with? I love arrows. Okay, 3x squared. I have my 3 taken care of. I have x squared and I want x cubed, so I need another x for the first term. Plus, for the second term, I have 3 and want 9, so I need 3. I have x squared, I want x squared, I'm done. Pause. Now I'm going to factor my second two. 2x plus 6, the greatest common factor for those two terms would simply be 2. 2 times what gets me what I started with? So 2 times, I need an x, and 2 times 3 gives me the 6 I started with. I have factored the first half and the second half separately, and then I look and say, can I find a common factor in both of these two terms that's the same? Yes. Just like the last question, I have a common factor of x plus 3 here for this term, and here for this term. So I write that as my greatest common factor and ask myself, what do I multiply it by to get the first term? 3x squared. What do I multiply it by to get the second term? 2. So when I look at my second line, my final answer will be that common bracket multiplied by the leftovers, the 3x squared and the 2. Second one, we're going to factor by grouping. I'm going to do these two. 10x cubed subtract 35x squared has a common factor of 5 for the numbers and x squared for the variables. 5x squared times what gives me 10x cubed? Well, I need a 2 and I need an x. Subtract 5x squared times what gives me 35x squared? I need a 7. I already have x squared. I don't want any more powers of x. I'm done. Pause. I'm going to factor the second 2. I do not see a nice number that goes into both terms, nor do I see an x in both terms. So there is not a greatest common factor that's more interesting than just a 1. So I'm just going to write the 1. What do I multiply? Now look here for a second. I have it written as take away 1. So I want both of the terms inside to multiply and change sign, which will give me 2x, subtract 2x plus 7. So be careful with your negative sign. Notice that the two brackets are now identical. So my final answer will be the common bracket and what I multiply it by, which would be the leftovers, 5x squared, subtract 1. Here's a question we've seen before. 6x squared plus 8x plus 9x plus 12. I'm going to factor by grouping. My first two terms, the greatest common factor for those two would be the number 2 and an x. What would I multiply that by to get what I started with? Well, I need 3 and another x for the first term, plus I need a 4 to make it 8. I've already got the x. I'm done. For the second 2, I need a greatest common factor, and a number that goes into both 9 and 12 would be 3. I only have x in one of the terms, so that can't be a greatest common factor. What do I multiply 3 by to get 9x? I need a 3, and I need an x. What do I multiply 3 by to get 12? Would be 4. Interesting. Notice the two brackets are the same again. So my final answer would be the common bracket, 3x plus 4, and the leftovers, 2x plus 3. If you've been very observant, you might notice that this second question on this page is the very same question. 8x plus 9x really is 17x. So if I asked you to factor 6x squared plus 17x plus 12, you know the answer is this. How could I get from question number 2 to that answer? By looking at it the way it's written right now. There isn't a greatest common factor for 6x squared plus 17x plus 12. It's not a simple trinomial nor a difference of squares. So my goal today is to write it with 4 terms like this one right here, so that I can factor by grouping. This is called decomposition. So I am going to rewrite this question where this middle term is decomposed into 2 parts so that I can factor by grouping. This is what we need to write down on our anchor chart. I need to decompose that 17x into 2 parts such that the 2 parts add to 17 so that I'm not changing the question, and multiply to, here's where it's weird, whatever 6 times 12 is, 72. if I decompose it in such a way, then it will work beautifully to factor by grouping. Two numbers that add to 17 and multiply to 72. I always think about multiplication. And 72, there are lots of choices. 1 times 72. 2 times 36. I wouldn't give you such a mean number to start with. 3 times 24. 4 times 18. Isn't this crazy? 6 times 12. And 7 times 8. Oh, sorry. 8 times 9. See, I forgot one. 8 times 9. So that's an awful lot of choices. But I would look to find which one of those adds to 17. And the only one that works is that one. So I would decompose this question to 6x squared plus 8x plus 9x plus 12. And that's the question I gave you at the top. And we can factor that one by grouping and end up with the answer 3x plus 4 times 2x plus 3. So I wanted to show you why it works. And now we're going to try one. Here we go. 6x squared subtract 7x plus 2. My mental checklist is, the way it is there a greatest common factor? No. Is it a nice, simple trinomial where I can just throw up two sets of brackets and put the right numbers in? No, because of this ugly 6. Is it a difference of squares? No. There's 3 terms, not 2. So I am stuck with decomposition. This is our last method, and it's when they're tricky with a number in the front. So with decomposition, I want to write this equation out with that middle term broken into 2 parts, such that the 2 parts add to -7 and multiply to whatever 6 times 2 is, 12. If I do that, then it will factor by grouping really neatly. Multiplying to 12, brainstorming here. 1 times 12, 3 times 4, 6 times 2. And we want these two numbers to multiply to a positive, so they both need to be the same sign, but add to a negative. The choice that works is that one if they're both negative. So I use those two numbers and I write my question out as 6x squared subtract 3x subtract 4x. Okay, if you've gotten that thinking written down, I'm going to erase it so that I have room to work here, but make sure you have a note of it. All right. Now that I've made it into 4 terms, I'm going to factor by grouping. That means I'm going to look at the first 2, factor those, and then look at the second 2. For my first 2 terms, the greatest common factor would be a 3 and an x. 3x times what gives me my first term? I need a 2 and another x. 3x times what gives me -3x? Well, -1. Pause. Now I'm going to do the second 2 terms. Sorry, I should make that a different color. I should do the second 2 terms. I am going to put a subtract sign, and the common factor for those 2 terms would be 2. 2 times what gives me 4x? I need a 2x. And 2 times what gives me 2? Well, I need a 1, but remember I have a negative here, and I want to end up with a positive, so I'm going to write another negative here. Your other hint is that both of those brackets should look identical. Final answer would be the common bracket and the leftovers. And if you did FOIL on that, you would get what you started with. The one below it, 3x squared subtract 2x subtract 8. I am going to decompose this such that I have two terms that add to -2. So I'm just going to write it differently, but it can't change the question, and multiply to whatever 3 times -8 is, -24. It's just this really slick trick, isn't it? Multiply to -24. We could have 1 and 24, 2 times 12, 3 times 8, 6 times 4. Do any of those ever add to -2? This one might. They're only 2 apart. If one of them is positive and one of them is negative, we can multiply to a negative. The larger one's going to be negative because we add to -2. I found my two numbers, so I'm going to decompose this as 3x squared subtract 6x plus 4x subtract 8, which is the very same question that looks different. First two terms. I'm going to factor those two terms, and shouldn't keep going to the right, but I'm running out of space. Common factor to those two terms would be 3 and an x. 3x times what gives me the two terms? I need another x for the first term. Subtract, I need a 2, because 3x multiplied by -2 is -6x. Plus, now I'm thinking about the second two terms. What's the greatest common factor for those two terms? It would be 4. 4 times what gives me 4x times x. 4 times what gives me -8? -2. Then I look and see the common factor to both terms would be x minus 2. X minus 2 times what for the first term would be 3x. For the second term would be positive 4. So I have my common bracket and my leftovers. There's one more at the top. I'm going to erase a bit of our work before, so I hope you have it written down. 9w squared minus 24w plus 16. I am going to decompose the middle term such that my two terms add to -24 and multiply to whatever 9 times 16 is. I'll tell you what I'm doing in my head. I'm doing 9 times 10 and 9 times 6 separately and putting them together. But you can use a calculator. It would be 144. What multiplies to 144? Well, the easiest one is 12 times 12. And coincidentally, if those are both negative, it would add to -24w. -12w, -12w. Here we go. With decomposition, I factor the first two terms and then the second two terms a little later. Greatest common factor for 9w squared and 12w would be 3w. I multiply that by a 3w to get 9w squared, and I would multiply it by -4 to get -12w. Pause. Now I'm going to factor the second two terms. Greatest common factor for 12w and 16 would be a 4. Don't forget your subtract in the brackets. 4 times what gives me 12w would be 3w. I have a negative, so I need to put the appropriate sign so that when I multiply I get a positive. This would also be a negative. 4 times 4 is 16. Careful of your sign, and notice that it's kind of like a little cheat, but your two brackets should be common or the same. So my bracket is 3w minus 4. That's my common term. And the leftovers are also 3w and subtract 4. You could write this, if you want to be interesting, as 3w subtract 4 squared. You need to tell your parents you've been doing algebra and you've been doing decomposition, and you should have lasagna for supper.